just turn my camera on for a second and say hello, and then I'll probably turn it back off to save a little bit of bandwidth as we go forward here. But really enjoy the opportunity to speak to everybody today. Listening to both Sam and Barbara talk and Jen kind of setting the stage. It really is an exciting time thinking forward about where we're going, what opportunities we're going to have to use the human architecture to study the moon, study deep space, think about how we spend more and more time going beyond low Earth orbit, both with robotics and humans, just to answer big questions that we have. So for those of you who don't know me, my name's Jake Bleacher. And I am a manager for our science, technology, utilization, and integration team in our strategy and architecture office over in exploration systems. So I work very closely with the people you've just heard from and some others you will hear from in the Science Mission Directorate, as well as the other directorates who are conducting science through Artemis, to make sure that we're developing our architecture in a way that helps us address the objectives that Barbara just talked about, but also making sure that the science that's being conducted helps us to understand that environment that we're being asked to build our systems to go explore. So that science, goes hand in hand with exploration as we're working through all the activities we have coming up. So if I could get the next slide, please. Appreciate it. So, many of you have seen plenty of presentations from us. The first thing I just want to say right up front is we are going to the moon. There may be a lot of noise out there right now about Mars, moon. We're definitely going to the moon. And I'll talk a little bit about Artemis 2, Artemis 3 here in the next few slides. But we're going there really to learn how to live and operate away from the Earth on other planets and, for the benefit of humanity. How do we do this? How do we begin to step away? We've learned a lot from low Earth orbit over the last several decades. And we did learn, as Sam kind of hinted at this, we have learned from going to the moon in the past with Apollo. But we're really on a different trajectory here. This is not the same. We're not going to, only conduct short stays. We want to begin to learn how to live away from the Earth, how to help humanity do that. With our Artemis effort, we're going to be building a longer term presence over time. Okay, it doesn't start with the first effort. Our first visits will be shorter. Barbara hinted at this, about the missions that are coming up with Artemis 3 and probably the next few that follow it. They'll be on the scale of about a week, and as we learn and get better at the approach, we will do everything we can to maximize our EVA time out on the surface of the moon. Everybody wants to get out of the habitable volumes and get onto the surface. And as we do that, as we learn these systems, as we learn about the new systems being developed with our industry partners across NASA, with our international partners, we'll be able to begin maximizing the opportunity to make those new scientific discoveries. So I just want to kind of set that stage early on. That is what we're doing. We're heading to the moon right now. Next slide, please. So I just wanted to lay out what the current baseline Moon and Mars architecture elements look like. If you have followed much about the Artemis architecture through our architecture concept review, you've probably seen slides like this or presentations like this, but we flew our first Artemis mission that tested out our ground systems, our launch systems, our human crew capsule, the Orion. Robotically, we showed that those systems work in an integrated manner. They can connect back to Earth through our deep space network and our space communications and navigation network. So, we've tested those systems out, and now we're in the process of getting ready to send astronauts on board to make sure we understand the ECLSS systems, our environmental control and life support systems. We can operate with crew in those spacecraft and bring them home safely, which puts us in a position then to use the new suits that are in design, the landing systems that are in design to get astronauts on the surface. Again, the goal here is over time to begin to increase the capability there. And what really sets us apart from past human missions to the moon is that the plan is to begin laying infrastructure in place so that we don't have to carry everything with us on every landing to the moon. So as we start to be able to depend on hardware that we've already deployed, that we've left on the moon after our previous crewed missions, that what that means is capability will increase. Our ability to get more to the surface and hopefully to get more back to the Earth will continue to increase. And that is what the process is that we're going through right now. And then through that, we'll begin to have hardware that can increase the amount of time we stay at the moon, habitats, so that we don't only have to live in the landers that we take with us. And then driving mobility to be able to move around and get to the places that you hopefully will be talking about later today. You know, we can't always land directly beside where we want to go. So we do have to increase our ability to stay longer and to move more. But again, it all starts with these first few missions that help us understand how our systems operate, and so we can get to that point. So I'll take the next slide, please. So I just want to talk a little bit about that architecture, and the way we are currently discussing is by breaking it down to what we call architecture segments. So right now, what I've just described to you is really our human lunar return. So this is where we're testing out those initial capabilities and systems. We're really learning about how we operate with those systems so that we can establish that presence at the South Polar region of the moon. So utilization, as Barbara noted, that's our NASA word that basically is science, tech dev work. But, you know, that's a part of that initial segment and all of the segments going forward. Again, and that increase in capability that will lead us to what we call foundational exploration. It's where we expand our infrastructure. We start having systems both in orbit and on the surface that increase our ability to do the work, to meet the objectives. That's what, you know, we'll step away from this human lunar return and start to have scenarios where we have longer missions, longer stays, learning again to live away from the Earth a little bit. Now, that foundational exploration, then, as we continue to increase those capabilities, continue to build with that infrastructure, leads into another segment that is a little bit farther in the future and a little bit lesser defined. And right now, we refer to that as sustained lunar evolution. And we don't know exactly how that evolves. What we do know is that probably is dependent on partnership. And what we're trying to understand is what do we, NASA, the United States government, need to put in place that welcomes and encourages that partnership so that we really can develop that longer term presence on the moon, maybe even permanent presence on the moon. And what really drives the development of that lunar economy? Who wants to be there? Who wants to be working there? And what can we provide to get that foothold so that they can get to that point? At the same time, that all those lessons we're learning about how to live away from the Earth leads us on to other destinations that are farther away. So as we see that increase in partnership, that capabilities that are coming from other partners, not necessarily only NASA, that will enable us to continue to keep one eye out there towards farther destinations like Mars. Again, the point being learning how to live away from the Earth and explore the solar system with astronauts and our robotic missions. And then, of course, those Mars missions, just like pointing off to the right at sustained lunar evolution, there will be future segments as well for Mars and maybe other destinations. We don't know exactly what they all look like, and I don't think we really want to rush and try and say that they will look exactly like this now, because we need to learn. We need the science that goes along with each one of these steps to help us understand that environment, to help us understand our operations so that we can develop those best segments out into the future. Next slide, please. Just wanted to, highlight we have flown Artemis 1. I mentioned that earlier. I'm sure you all are well aware of that. That uncrewed flight test that gave us a chance to see how the Orion and the SLS worked as we flew uncrewed out around the moon and came home. So that puts us in a position now for Artemis 2 to do a very similar mission, but with crew, to really test out our systems, understand how our astronauts respond to the way the systems are designed, understand our life support systems, and really monitor that as we fly. This is a really exciting time right now. It gets very real when you have your friends on board, and we all take that very seriously. Their safety, the safety of our friends, our NASA family is of utmost importance. So everybody's working really hard right now to get this mission going, and we're expecting to fly that in the first quarter of 2026. And all signs right now are indicating that we're on that path. And then that leads us to Artemis 3, which is that first human landing on the surface of the moon, which opens up the doorway to the missions that come after that and can begin to explore more and more as we go. Next slide, please. Just to highlight a little bit, you again maybe have seen these slides, but Artemis 1 now complete. It was that first integrated flight with all of the systems that we had in place. It really lays the groundwork for how those future segments will develop and evolve as we go forward. So continuously reassessing what we've done, learning the lessons from those missions so that we can design the next missions and move into that future segment for foundational exploration with ever increasing capability. Next slide, please. So again, here we are now getting ready for and preparing for Artemis 2. And again, I've said it several times, but this has the first time that we'll have our crew on board. This will be the first time we have astronauts looking at the moon, as Sam noted, in several decades. It is really exciting. It's really exciting to have systems in place that, are now the basis for how all of our systems will evolve to enable us to conduct human exploration going forward. So again, we're driving hard towards that flight. Just want to point out, the stack continues to grow down at the Cape. We've got Orion down there now being integrated with the abort system, and that just started last month. So we really are driving towards that first quarter 2026 date to get this mission going. So it really is exciting as all those things are coming together. There's a lot of training going on, a lot of looking at how we retrieve the capsule when it comes back. We'll be splashing down off the coast of San Diego. It's a lot of work, multi-agency work on how we do that. So a lot of parts coming together now. It's really cool to see them all these what seem like separate threads over the last couple years starting to come together in what is the Artemis 2 mission. So very exciting time right now for that. Next slide, please. A lot of science as well. I think Barbara hinted at some of this, and we'll be able to look at the moon for the first time in several decades. We're going to be monitoring that deep space environment with a suite of sensors that help us understand what's going on. We're also carrying again CubeSats that will deploy, although these will be deployed into an Earth orbit this time, unlike the Artemis 1 effort. Most of those all of those CubeSats are international, and most of those will be also continuing to monitor how the Earth environment interacts with that deep space environment. So net integrated approach there, collecting a lot of data. This slide's already a little bit out of date because we just recently had the crew sign off on a series of studies in which they are basically the subject. So stay tuned. Some information coming out very soon about how we're going to study the crew responding to that environment and biology in general. So we have a couple of activities coming up here in the next few weeks where we'll relay some more details to that, and you'll see some updates to slides like this. Next slide, please. Again, just wanted to throw the picture of the crew out there for you. These folks going through a lot of work right now, taking this very seriously. And it really is an exciting time, especially we've got an international partner here with Jeremy Hansen, Reed, Victor, Christina from NASA, really focusing in. And I know they're working closely with our science folks and getting the training they need to conduct the science they're going to do. Next slide, please. And then that puts us in a position for Artemis 3. So I'm not going to dwell on this too much, but once we know our systems are dependable and our astronauts are going to be safe flying in them, that puts us in a position to take the next step, which is landing them on the surface of the moon. So Artemis 3 will really set the baseline for how we begin to explore in, again, what you'll be talking about here, future missions beyond Artemis 3 that help us start answering and really starting to address some of those big objectives. Next slide, please. The science, I won't dwell on this a whole lot because this comes from our science mission directorate friends and our human research friends, but we have deployed payloads. Many of you might be on those teams or have competed for some of these spots. We had SMD as a science team. We're working closely with HRP as well, the Human Research Program, to collect input on how they're going to conduct their research. So again, the points that Barbara made, science is integrated into these discussions as we go forward, and Artemis 3 will be the first chance for us to really look at how we do that on the surface. Next slide, please. So I just, wanted to make sure you understand we've got a lot going on. We continue to press forward on lunar exploration. We're flying an orbital mission with Artemis 2, and then Artemis 3 getting on the ground to set the stage to open up with expanding and increasing capabilities for science in the future. Just, this is where we are right now. We have a strong focus on lunar surface capabilities in the work that we're doing. NASA's been asked to explore commercial transportation services to make sure that we have a robust approach to getting astronauts out to the moon and down to the surface of the moon. Along with that, we're focusing on lunar sustainment activities that enable us to stay on the moon for longer periods of time and prepare for going to farther away destinations like Mars. And we do have announcements that have come out about putting power systems down on the surface of the moon. So again, the message hasn't really changed. Over the last year, we are continuing lunar exploration. We will continue to develop and increase capabilities on the surface, all of which will enable us to do more science. So I hope that you can really have some good conversations later today. Thinking about how you meet those objectives or begin to contribute to those objectives, as Barbara mentioned, and think about these capabilities and think about how moving forward we can continue to do that work together collaboratively with human exploration. I think that's my last slide. So I'll hand back over to Sarah. Thanks, Sarah.